So today, the student will be able to determine if two equations are inverses of each other using compositions. So we have been talking about inverse functions, and you're going to determine if things are inverse again today, but we're not going to use their graphs, and we're not going to use their tables, or we're not going to use the equation like we had before. But before I can tell you how to use compositions to do that, we need to remember a couple of things that you should already know. To start, if I ask you to evaluate the function f of x equals 4x plus 7 when x equals -2. Right now, I have a function that I'm deciding to call f that's made up of x variables on this side. If I change x to -2, then I'm using this function I'm still calling f, but instead of x, I'm using -2, and I need to see what I'll get out when that's the case. So my function when x is -2 is equal to 4 times -2 is -8 plus 7. That gives us -1. So what we know here is we know that the function when x is -2 has an output or a y value of -1. That's what this answer tells us. So don't forget that you can take any input, put it in the input part of the function, and get a number out, get a value out. Now, something you probably also remember from Algebra 1, maybe, is composite functions. If I give you one function we're calling f, and one function we're calling g, and I ask you to find f of g of x, I could also write that in this way. I could say I want you to find f of g of x. And those are the same thing. So this small, like open multiplier looking sign means of, f of g of x. So what we're going to do now is normally I have f of x, but my input has become all of g. So I'm going to take all of g and input it in the input of x, or f. So I have f, instead of x, I'm going to use g, and g is 4x minus 7. So I have 2 times 4x minus 7 plus 3. So I just replaced x with what g is equal to. All right, so now f of 4x minus 7 was really g of x. It's equal to 2 times 4 is 8x. 2 times -7 is -14, plus 3. Combine like terms. So the function, when g replaces my x's, is 8x minus 11. I can also do that the other way. Now they want to know g of f of x. So in this case, f is the input inside of g. So I'm going to start with g. So g of x is 4x minus 7, but I'm going to replace x with everything I know about f. So f was really 2x plus 3. 4x becomes 2x plus 3 minus 7. Okay, so g of my f function, 4 times 2x is 8x. 4 times 3 is 12. Combine your like terms. So g of f of x is 8x plus 5. Okay, so basically composite functions means just like you could take a normal input, plug it into a function and get an output, you can do the same thing with entire functions. So I can take this entire function, put it inside of another, and then find what I get out from that. So it's kind of cool. You're just moving things together. Okay, now, how do I use composite functions to prove that two equations are inverses? Okay, here's the rule. If f of g of x equals x and g of f of x, so the other direction, also equals x. If both of those things happen, then f and g are inverses. So we know how to take one equation, switch the x's and y, and solve for the other. But composite functions is another way you can test to see if two things are inverses. So the first thing I'm going to do is take f of g of x. So f of g of x means that I start with f, which was x plus 1 over 3. But now, instead of x, I'm going to put all of g inside of it. So instead of x, I'm going to put all of g. And g was 3x minus 1. Keep the plus 1 over 3. Okay, now I'm going to simplify. I don't have to keep the parentheses because there's nothing to distribute. So 3x plus, oops, my bad. 3x minus 1 plus 1 over 3. Minus 1 plus 1 is 0. So 3x over 3. And 3 divided by 3 is 1, so I have a single x. So f, when g is the input, is equal to x. Awesome, that worked. Well, now let's find the opposite, g of f of x. So I'm going to start with g was 3x minus 1. Now, I'm going to put the f function inside of the g. So I have 3 of, instead of x, we're going to use what f was, x plus 1 over 3, and then minus 1. Okay, so if I multiply this out, this is really 3 over 1. So 3 times x is 3x. 3 times 1 is 3. All that is divided by 3 minus 1. 3x divided by 3 is a single x. 3 divided by 3 is 1 minus 1. Negative 1 and positive 1 cancel out to 0. So I end up with g of f of x equals x. So because both of these came out to be x, then I can say yes, these two functions are inverses of each other. And that's it.